All right, guys, today we're going to be doing section 2.4, completing the square. We're not going to finish this today. We're just going to really get started with it. Eventually, completing the square will be another tool that you can use to solve quadratic equations. So far we've done graphing to solve them, we've done factoring to solve them, and today we're going to be doing some square root stuff and completing the square. So to start out, we're starting out with the square root property. And we're saying that to solve a quadratic equation, you can take the square root of both sides. And we did this one day in class. And again, the big thing to know is that when you take the square root of something, that you could get either a positive or a negative value. The idea being that, for example, 2 squared is 4, but if I take negative 2 squared, that would also be 4. So if I took the square root of 4, I could get positive or negative 2. And in math, we would say plus or minus 2. So to use this to solve this equation, I'm first going to get the 4x squared by itself. So I'm going to subtract negative 11 from both sides. And now I'm going to divide both sides by 4. Again, just getting that x squared by itself. And now I'm going to take the square root of both sides. And so I would get x to be positive or negative square root of 12. 12 is not a nice perfect square. So I'm going to see if I can simplify it. I'm looking for any perfect squares that do go into 12. And there's 4. And I know that 4 times 3 would be 12. And so writing it this way, as the square root of 4 times the square root of 3, that is the same thing as the square root of 12. And it's just letting me simplify this a little bit. So now I can say that my answer for this would be that x could be positive or negative 2 times the square root of 3. The square root of 3 is irrational, so we're just going to leave it at that. We're not going to try to estimate as a decimal. We'll leave it exact, just like this. So next one. Solving equations using the square root property again. This one's different because now I have a term here in the middle with my 12x squared. So we're going to try factoring to help us out here because we've already worked on that. And I could do x times x, and I could say x plus 6 and x plus 6. When I multiply that out, I would get 12x in the middle and 36 on the end. And I can rewrite this as x plus 6 squared equals 28. And now I could take the square root of both sides. And I would get x plus 6 could be equal to the positive or negative square root of 28. And I still need to simplify all this. I'm first going to simplify the square root. I can break 28 into 4 and 7. 4 is a perfect square there. And so I would get plus or minus 2 times the square root of 7. And then I'm just going to subtract 6 from both sides. And so I would get x to equal plus or minus 2 times the square root of 7 minus 6. I can't combine those. Those are not like terms. So I do have 2 roots here, if you notice. There are still 2 roots because I have the positive and the negative value. So if I'm graphing this, this is still going to cross the x-axis twice. All right, now here's this one. I want you to try this on your own and pause the video for a little bit and then come back and see how you did. Go ahead. Okay, so if you tried to solve this one, you probably got to the point where you had x squared equals 25 over 4. And I just wanted to start from here just to show that if I take the square root of both sides here, I would get x to be positive or negative the square root of 25 over 4. And we can simplify that a lot. So I can take the square root of both the numerator and the denominator. So square root of 25 is 5, square root of 4 is 2, and there we go. I could change this to plus or minus 2.5, but I can just leave it this way as well. So again, 2 roots. X could be positive 2.5 or negative 2.5. All right, so now we're heading into completing the square. And when we're talking about completing the square, keep thinking that we want to write something in this form as x plus or minus something in parentheses squared. And so our goal is to, right now, try to figure out what number needs to be at the end of our trinomial, 3 terms, to make this a perfect square, to be able to write it as x plus or minus something in parentheses squared. So yesterday you worked on a Desmos activity. You had visuals like this, where we were actually taking figures and making them into squares, and we had to figure out what needs to be added in there to make it a perfect square. And if we look at it this way, I have x plus 3 here, and I have x plus 3 here. So the area of that whole square would be x plus 3 times x plus 3, which is x plus 3 squared. So there's kind of the visual of what's happening when you're completing the square. Okay, so now when we are really trying to figure out what number can go at the end to make this a perfect square, I like to think of it just like factoring. And I'm going to split up my x's, and I know that I need to get negative 14 in the middle, and I also know that these 2 terms need to be exactly the same. So I'm going to make them both negative, and the only thing added together that's going to get me negative 14 is 2 negative 7s that are the same. And so when I do that, now I multiply it back out, and let's see what I end up with. X squared minus 7x plus 49. So the number that needs to go at the end here to complete this would be plus 49. Because when there's that number there, I could rewrite this whole thing as x minus 7 squared. Now just keep in mind that right now we are essentially changing this expression. X squared minus 14x is not the same thing as x squared minus 14x plus 49, right? Those are 2 different things right now, but we're just trying to get to see some patterns at how can we get this plus 49 number? How can we figure that out? Your book is going to talk about taking your term, your b, dividing it by 2, and then squaring it to get that last number. And that's exactly what we did. Negative 14 divided by 2 is negative 7. And then when we squared that, negative 7 times negative 7 got you 49. I just like to think of it as factoring because for some reason it works in my head and then I don't have to memorize this, but the rule that your book gives you will be a shorter trick. So here we go. Now we have this one, x squared plus 9x plus something. We have to figure out what is that something to make this a perfect square. Again, I'm thinking about factoring, and both of them have to be plus, and I'm thinking what needs to be added together that is the same thing to get me 9. Well, that's going to be 4.5 or 9/2. And then when I do that and I multiply it all out, I get x squared plus 9/2x plus 9/2x plus, and then 9/2 times 9/2 is going to be 81/4. Okay, and I can see when I simplify that I would end up with what I needed. And I've completed this square because now I could rewrite this as x plus 9/2 squared. And I did still use the book, or the rule from your book. I took my b, which was 9, I divided it by 2, and then once you square that, that is 81/4, and that's what went at the end. Okay, so there's your kind of intro into completing the square. I want you to try this one on this page, or on this slide, on your own. See what you get, and then come back to it. Come back to the video, I mean. Good luck. Okay, you've tried this on your own now. The binomial squared that you should end up with is x plus 2 squared. That's this right there. And again, I showed how you could think through it using factoring that you've already done, and also using the rule that your book gave you. So that is where we're going to stop for today. And if you have questions, please be coming in. I will be back tomorrow, so come in the morning, and I'll be happy to help you out. Have a great day.